Hello, welcome back to the second video in the series of explanation on the standard deviation formula. So in this video, I'm going to introduce you to standard deviation. We're going to start with something intuitive, something visual like a graph, where you can see what standard deviation is. And hopefully from there, we can build a good understanding on what it actually is. Now let's first look at the word deviation. What does it actually mean? Deviate, you kind of see the phrase deviation from a norm. It means you're not like the rest, kind of sticking out some sort. But for statistics, right, sorry for distracting you, but actually there is a proper definition for statistics. What it means is that how much a single measurement or a single piece of data differs from a fixed value such as the mean. Okay, a lot of words, what does it mean? Like I promised, let's look at pictures. Over here we have the sales over 6 months of somebody. And if we average it out, you actually get a red line that's drawn across. Okay, so how much a single measurement, a single piece of data, for example, the amount of money, right, made from sales in January is a single measurement, right? So we want to see how much this measurement is different from the average. Now say the difference is this distance over here, this tiny little difference. Sorry, I couldn't be more exact because the marker is quite hard to write with. But from the top of the bar to the red line, that's how much the difference is. Yes, that is the deviation we are talking about. Okay, for February, the next measurement, the next piece of data, it is a bit more obvious, right? This one I can draw a bit better. It's from here, the red line to the top of the bar. That is the difference. That is the deviation. Right? March is kind of near the average. I can't really draw anything. April is about like this. May is about like this. And June. Okay? So now I hope you have a good understanding of what deviation actually is. Now, let me ask you a question. Is this deviation considered huge or small? Right? That's a good question. The answer is, it depends. It depends on what you're comparing with, right? Okay, if you're comparing with this one, this green graph over here, then this green graph has a larger deviation. You can see it straight away, right? The distance between the top of the bar and the red line is so much bigger than the blue one. Can you see? So we definitely can feel that the deviation is larger for the green graph. Now that we know what deviation looks like, let's try and calculate it. Let's try and add up all the differences in the blue graph. Suppose, okay, I have extracted out all the data from the Excel file, right? Microsoft Excel is an excellent program. You should use it for statistics. So, deviation, right? So let's just say that is the amount of money made from the measurement and how much it is different from the average. So sales minus the mean. For January, we're going to take 120 minus 124.17. And that will give us a negative value, negative 4.17. Right? Continuing with the rest, right? Excel does this very well. Right? So it calculates for you automatically. All right. Would you like to first make a guess before I review the answer? What is the sum of all the deviation for this blue graph? Right? Keep in mind that it's supposed to be small, right? It's supposed to be small. Okay, so I'm going to review in 3, 2, 1. Total deviation is 0. Could it be that, yeah, the deviation is really small, so it's around 0? Let's maybe check with the green graph where the deviation is larger. Maybe we'll get a non-zero value over here. All right? Again, I'm going to use the same formula, sales minus the average. For the first month, that is 175. Pretty good. And Excel does the calculation for the rest of the months. And what do you think is the sum of the deviation over here? So again, 3, 2, 1. It is also 0. But why is it 0? We can clearly see that there's so much difference from the average from month to month. But why is the deviation 0? Right? Why is the deviation 0? So let me explain to you. If you think about average, when we average things out, for example, the green graph, let's think of January, February to June, the 6 months. Let's think of them as people. Maybe January is a woman, February is a man, so on and so forth. The 6 of them gets together and say, hey, let's put all our money together and then we divide by the number of people. That's average, right? So what happens? The people who have more end up sort of like giving to the people who have less, and those who have less will be receiving from those who have more. So what we did was we took this and then we, minus it off because this guy has a negative deviation, right? And this guy, we added him and then we minus off and we minus off. Guess what? We were averaging out the values, and that is why we got a 0 deviation. So this is not the correct way to measure deviation across all your pieces of data. What would be a better way? Right? A better way would be to take all this and add together. Say I have the long bar here, I want to add. I don't want to subtract negative values. Right? This is a negative value, but I want to add it. What should I do so that I can add negative values instead of having them being taken away from the cumulative sum? That's right, I think you have guessed it. We should square. We should square the values. Squaring removes the sign, right? And then we're going to sum it all up. Sum up all, right, all the squares of the differences. Okay? So, but the only problem is when you square things, the magnitude gets bigger. Yes? So like 3 times 3 is 9. It becomes 3 times bigger. 4 times 4 is 16. It becomes 4 times bigger. When you square, the magnitude blows up, right? So we have to introduce a square root at the end of it all. Agree? Yeah? So we are squaring to remove the negative sign, but we do a square root after we sum everything. Yeah? That sounds like a good way to balance things up. So using this new method, right? Again, we use the Excel file to calculate. This is the new deviation, 41.48. Let me quickly show you the green one. It is 234.84. And this is very good. Why is that so? We have finally come up with something that tells us, right, this is a good way to measure, right? This is bigger and this is smaller. Oops, maybe I'll use an arrow. This is bigger and this is smaller. Yes, we got a good formula to measure deviation. Yes? Yes? If you recall, deviation was actually the definition of deviation is how a single measurement differs from the mean. So, what does 41.48 mean? What's the meaning of this number? Are we saying that each of the single value, for example, January, is $41.48 away from the average? February is about averagely 41.48 away from the average? I don't think so. What are we missing? Right? And the thing that we're missing is we need to divide by the number of values. When we sum up all 6 pieces of data, we then have to divide by 6. Right? So we should divide by the number of values. Okay? Doing this will give you standard deviation. Right? So this is the intuitive formula, the intuitive version of the formula of standard deviation. So we are not yet at the one that is in your textbook, right? So let me just do a quick revision to show you our progress, what we started with. We started here. We started summing up each value minus the mean. That didn't work because we are kind of like evening things out, right? Averaging things out. Right? Sorry about the planes flying by. Hopefully you can still hear what I'm saying. Right. The next thing that we did was, hey, we realized that we don't want to add. We don't want to have negative values, negative differences affecting our cumulative total. So we're going to square to make the negative values positive. So we want to sum up the squares of the values, but at the same time, when we square things, the magnitude gets blown up. So we square root it to keep it small, right? So this is what we arrive at our next step. But when we sum things up, if you have 6 pieces of data, then we should divide by 6 to make it fair. Right? And then we divide by 6 the number of values, and this is what we arrive with. This is the intuitive version of the formula. Now, in the next video, I think it's the final video, I'm going to show you how I'm going to convert this version into the one in your textbook or in your notes. Yeah? Okay, so see you in the next video.